Hello everyone. Today we are going to solve today's daily question. Find x sum of all k long subarrays 1. So I hope so that you have read the question. I will explain you the first test case. So here is the first test case. Now here what we are given is we are given a input array, input nums. So here what we need to do is we need to find the first we need to find all such subarrays ending at k to k and ending at k till ending at n, and find all the most occurring elements. Like here, let's see, if in this example we have k equals to 6, so 1 2 3 4 5 6 7 8. So the subarray ending at 6 element, this is the first subarray. 1 to 6 is the first subarray. Second subarray is 2 to 7. Third subarray is 3 to 8. So in both of these three subarrays, we need to find the x most frequent elements. What are the x most frequent elements? Like in 1 to 6, we can see that 1 1 2 2 3 4. So 1 occurs 2 times, 2 occurs 2 times, and 3 occurs 1 times, and 4 occurs 1 time. So most occurrent elements are what? 1 and 2. So we need to return one sum of all these elements, 1 1 2 2. So what it is? 1 plus 1 plus 2 plus 2. So for another subarray from 2 to 7, what will be the subarray? 1 2 2 3 4 2. Now here, what are the frequencies? 1 has a frequency of 1, 2 has a frequency of 2, 3 has a frequency of 1, 4 has a frequency of 1. Sorry, it is not 2, it is 3. So what we'll take is, we will take the most frequent elements. So first of all, most frequent is 2. So if we will first take 2 plus 2 plus 2. Now which is the second most frequent element? Is it 1, 3 or 4? They are both the same. So what we will do in this case is, we will take the most maximum element, which is 4. So take plus 4. So what this will result is 6 plus 4, 10. 10 will be our output. So similarly, we will create this subarray, and in this subarray, what will be happening is, 2 has a frequency of 3, 3 has a frequency of 2, and 4 has a frequency of 1. So obviously we will take two most frequent elements, which are these. 2 occurs 3 times, 3 occurs 2 times, which is 6 plus 6, which is 12. So in this way we can solve this question. But what will be the algorithm? How can we solve this question? So basically, I hope that you have learned sliding window. So we will here use sliding window. What we'll do is, we will let me erase this. Okay, let me do here only. Here what we'll do is, a1 a2 a3 a4 dot 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 an. So suppose this is our array. Okay, so now what we'll do is, we will keep on increasing our window, but decreasing from left, increasing from right, decreasing from left, increasing from right, and we will take a map with us. What will this map will keep us is the number and its corresponding frequency. We will keep these in our map. So we will keep the frequencies till the kth position, and then increment from the left and increment from the right, so that we can shift our window continuously. And when we are at a particular window, how will we find that which is the element, which are the most frequent elements? So for this, we will create a solve function. In this solve function, what we will do is, we will create a vector. In this vector, we will store the frequency of that element and the number, and just sort it in what order? Sorted in decreasing order of frequency and decreasing order of num. For example, I will take this example for a little bit more clarity. Which example? Here, for the second subarray, I am taking example like 1 occurs 1 time, 2 occurs 3 times, 3 occurs 1 times, and 4 occurs 1 time. So this is my map. This whole structure will be my map. Now how will I store it in my vector? I will store it in a reverse order. Like this is the number and this is the frequency. In my vector, I will store it in a reverse order, like frequency to 1, frequency to number, frequency to number, frequency to number, and frequency to number. Now I will just arrange it in a decreasing order of number. Sorry, this is decreasing order of frequency. And if at certain point of time, if my frequencies are same, I will arrange it in decreasing order of my number. So let's start. First it will come 3, 2. It is gone. Now which will be the element next? it will be 1 or 1. So these have same frequencies. So what will I do? I will take the bigger number, which is 4. This one, 1 to 4, then 1 to 3, then 1 to 1. So in this way I will just arrange my vector, and then from here I will take the first x elements, x1, x2. X is 2, so 1 and 2. So I will take these two numbers, and it will just give me 3 to the 6 plus 4 1 the 4 is equals to 10. So in this way I can solve this particular question. So let's see the code here first. I will explain you line by line, don't worry. So here first of all we will just declare a vector and result, and as I told you I will just create a map here. I have done map. Okay, I will store all the elements in the map. Now I'm creating a sliding window, j equal to k minus 1, I equals to 0, because my first subarray is ending at k minus 1, 0 based indexing. Okay, 0 based. So now I will just first of all push well in my result. What is this solve function? What is this solve function giving me exactly? Let's see that. So here it is my solve function. So as I told you, I will create a vector element vec frequency comma number. This is what will be stored in my vector. But in my map, what was stored? Number comma frequency. But in my vector, we will store frequency comma vector. So I'll just in my vector push frequency comma vector, then sort vector begin vector and comma comp. Now what is comp? I hope so you have learned comparator function, bool static comp, that we declare that if my first elements are equal, I will return dot second greater than dot b dot second, else I will return a dot first dot b dot first. Now a is occurring first and b is occurring second. This is what we usually do in our comp operator. This is our standard function. So what we are doing is we are arranging it in a decreasing order. If we would have to increase, so stored it in an increasing order, then what we have done is we have just used this inequality, a dot second less than b dot second, and here also a dot first less than b dot first. But since we have to store it in a decreasing order, we will just reverse the inequality and do like this. Okay, so this is what our comp operator is. So that's how we will store our vector. So now while our x minus minus, we will just keep on doing the sum of vec I dot first star vec I dot second, so that we can get the sum of all the elements which are present in the top x part, right? And if I equal to 1, break, and we will just return the sum here, and here we will get the sum as well. We will push it in the result vector, and then now we are shifting the window from left. So MPP of nums of I minus minus, and if the number is equal to 0, you will just erase it, and then increment from left, increment from right. It is for right, j is for right, and I is for left, right? And if j is less than n, we will just increment the right side of the sliding window, and then just return the resulting vector, which is res. So in this way we can solve this particular question, and this one is a very easy question. The only issue in this particular question is it is a little bit of implementation based. If your implementation in basic STL type of things is good, you won't be facing any issues. So I hope so that the whole part is cleared. And for the time complexity, for this whole particular question is big of n. Big of n. Why? Because we are traversing only once through the whole array. This sliding window, then this sliding window. We can see the right part is increasing like this linearly. So big of n is a time complexity. But this is the time complexity of only the solve function, right? But here, if you can see, sorry, not solve function, find x sum. Here we are calling the solve function again. So it would be, so here, what will be the time complexity? It would be, again, big of n into, here, when we call the solve function, we are sorting the array also. So for sorting, let the size of the vector vec be k. So it would be sorting for vec would be k log k. So the whole time complexity would be n into k log k. So it would be time complexity. And what about the space? It is big O of n for the map and vector also. So overall it is big O of n. So I hope so that you liked the question. Thank you.